All right, let's start, guys. Let's start. All right, notes 32, integral as a net change. So we're doing this. Originally, notes 32 was going to be more antiderivatives and all that good stuff, but I feel like we need to talk about this right now. All right, so this is from the 2012 AP exam. No calculator. Let's see if we can do this. Let's read it, guys. This is a no calculator question. It says a tank contains 50 liters of oil at time t equals 4 hours. Oil is being pumped into the tank at a rate of R of t, where R of t is measured in liters per hour, and t is measured in hours. Selected values of R of t are given in the table above. Use a Wright-Riemann sum with 3 subintervals and the data from the table. What is the approximation of the number of liters of oil that are in the tank at t equals 15? All right, they're giving us a lot of stuff. Relax. First and foremost, they want us to use 3 rectangles determined by the table. So they're not going to be equal width. Notice, here's the width of the first rectangle. What's the difference between 4 and 7? 3. I guess I should have said what's the difference between 7 and 4, but whatever, it's the same thing. And then you're using a Wright-Riemann sum. So am I using the 6.5 or the 6.2? The 6.2. So put 3 times 6.2 plus, what's the difference between 12 and 7? 5 times, and I'm going to use the 5.9 plus, what's the difference between 15 and 12? 3, and I'm going to write, that's half the battle. All right, now can we do this without a calculator? Well, let's see. I'm just going to tell you how I do it, and then if you're more efficient than me, that's cool. I do it like this. I do 3 times 6. We can do that really quick, right? 6, 12, 18. And then I see there was a 0.2 attached. I can add 0.2 3 times. 0.2, 0.4, 0.6. I'm adding, 0.2 every time. So this is going to be 6, 12, 18, 18.6. Do you guys see how we did that? Plus 5 times 5.9. I can't do that immediately, but I can do 5 times 6. 5 times 6 is 30, but I did that 5 times. But this is not a 6. It is a 5.9. The difference is 0.1. So this has to be 29.5. Because, do you guys see what I'm doing? Oh, this one. Okay, relax. Look, 3 times 5 is 15. And then I see that 0.6. I can add 0.6 3 times. 0.6, 1.2, 1.8. See? So 15 plus 1.8, 16.8. See? And now let's see. What am I going to do first? I think I'm going to do these two first. So I'm going to add 29 and 18, and I'm going to add 1.1. So 29 plus 18. 29, I'm going to add 20 and then subtract 2. 39, 49, subtract 2. 49, 48, 47. 47, and I'm going to add 1.1. 47, 48.1. That's what I got right there with those two. Now I'm going to add, that's 16.8. So I'm going to add 17 and then subtract 0.2. 48, 58, 58, 58, 58, 59, 64.65. So 65.1 subtract 0.2, 64.9. There we go. Do you guys see how I did it, guys? I mean, that's how I do it. You don't have to do it that way if you can think of a more efficient way. But hold on. Did some of you already circle letter A? Don't circle letter A yet. See, you're going too fast. Slow down. They want to know what is the approximation, what is the number of liters of oil in a tank at t equals 15 hours. Chop, well, that's what it is. We did our RAM. Guys, how many liters were already in the tank? So this is the approximate that we've added to the tank. Does that make sense? So you must add 50 to this initial. Must add 50 liters to 64.9 liters. Chop, how do you know that these are liters? Area under the curve, guys. Look what this is. This is a rate. Liters per hour times hours is just liters. Does that make sense? So hopefully everything makes sense. And there it is. So add 50 to that and you get 114.9. Cool or not cool? Okay. No, don't say sure. Say like, yeah, we got it.
Yeah, we got it.
Okay, we got it. All right. So check this one out. It's the same thing. It's a no calculator question. It says the values of the continuous function f are selected values of x are given in the table above. What is the value of a left Riemann sum between 0 and 50 f of x using the subinterval? So these are the intervals they want me to use. So here we go, guys. They're being nice. They gave us a table with just those values. If not, we would have had to have, gotten them from there. So look, my first delta x is 25. So 25. And they want me to use a left Riemann sum. So underline left Riemann sum. So I'm going to use that 4. 25 times 4. Plus, what's the gap between 25 and 30? 5. And I'm going to use what number? Perfect. Plus, what's the gap between 30 and 50? 20. And I'm going to use what number? There it is. Now, can we do this without a calculator? Yes. 25 times 4 is 100. 5 times 6 is 30. And then 20 times 8, 20, 40, 60, 81, 120, 40, 60. 160. Excuse me. Let's see. 100 plus 160, that's 260 plus another 30, that is 290. There was no units on this one, so there it is. How do we feel? Okay. All right, guys. So really quick, from physics, and no yawning, that's a demerit. Oh. I've had enough. Relax. It's baby physics. Let's say you start at point A. This is a bird's eye view. Bird's eye view. So imagine you're a bird. This is a bird's eye view. You're point A. And you go 3 meters to the right, or 3 meters east. And then you go 4 meters north. So this is a right angle right here. What is the distance that you just traveled? Yeah, 3 meters plus 4 meters, which is 7 meters. That was pretty easy, right? Okay. What is the displacement? The displacement is not 7 meters. The displacement is the net movement from point A to point B, which would be this linear line. You see that it's a right triangle, so that linear line has a distance of 5 meters. It's a 3. You can do Pythagorean theorem if you want, but hopefully you know that's a 3, 4, 5 triangle. So displacement, let me write displacement, is 5 meters. Does that make sense to you? I guess I should have just done moving right and moving left, but oh well, too bad. I wrote a north one. Cool or not cool? Okay, scenario 1. Let me do one more. Scenario 2, I'm going to do it in blue. Okay, let's say you start at this point A, and I'll keep it simple. I go 5 meters right. And then I get to that point, and now I'm going to move. I'm just moving right or left, so I'm actually not moving down here. Now I'm going to move 7 meters left. So my total distance that I traveled is 5 plus 7, right? Yeah, you're not actually moving down. I'm just telling you, you move 5 meters right, and then you move 7 meters. So you're standing still somewhere, and then someone tells you, move 5 to the right. And you just hop. Okay, you don't have to hop. Oh, sorry, chair. Sorry, chair. And then you move 7 meters to the other way from where you were originally at. So the distance you traveled, you went 5 to the right and then 7 to the left. So add them up together, and that's how much you traveled 12 distance. But that's not your displacement. When you started off, you were right here, and now you're how many units to the left? 2. Yeah, so your displacement is -2. So on this one, sorry guys, I didn't mean to hit the table here. 7, 8, 9, 10, 11, 12. All right, nothing crazy, right? All right, so let's look at this, guys. Let's go slow. A particle moves along the x-axis, units in centimeters. Its initial position is at 15. So, child, why does it say it's a 0? Because I'm just moving on the x-axis. I'm either moving left or right. Does that make sense? Okay. The figure shows the graph of the particle's velocity in centimeters per second. So what is this? A velocity time graph. Here's 0. Here's the y-axis. Here's the x-axis. The numbers are the areas of the enclosed regions. Okay. Nothing crazy. We haven't done anything crazy yet, have we? All right. So what are the values of? So here I have some integrands. We know about integrals. This is from 0 to a, v of t. This is my velocity. This is my v of t right here, this curve. So from 0 to a, I see a 4. That's the area, but it's below the x-axis. So this integral is -4. So put -4. From a to b, this integral is 5. And from b to c, this integral is... Okay. Perfect. Nothing crazy, right? All right, letter B. What is the particle's displacement between t equals 0 and t equals 7? Well, the particle's displacement, look, I go 4 to the left, 5 to the right, 24 to the left. What is the particle's displacement? Yep, that's what it is. So I go 4 to the left, negative 4, and then I go 5 to the right, and then I go 24 to the left. So I'm just adding them up. Do you see what I'm doing, guys? Okay. So negative 4 plus 5, that's 1, minus 24, that's negative 23. And I guess let's put units, centimeters. I don't see anything crazy. What is the particle? Yep, everything looks good to me. What is the total distance traveled by the particle in the same time period? Well, if I want total distance, instead of that being a negative 4, I have to take the absolute value. So what's the absolute value of negative 4? 4, and then 5 is already positive, 5, and then that negative 24 turned into a positive. And what do I get? 24, 5, 29, plus 4, 33 centimeters. Are we doing anything crazy so far? All right. Give the positions of the particle at times A, B, and C. Okay, I'm going to do it formally. Maybe it may not make sense to you initially, but bear with me. I'm going to clear it up in a little bit. So if I want a position at A, so I'm going to say I want x of A. I take my initial position that I have, which is the 15. Do you guys see that? So I'm going to write it like this. I take x of 0, and I'm going to add the displacement, the integral from 0, whatever that limit is, to A of v of t dt, because that's displacement. Let me circle it here. This is the displacement from t equals 0 to t equals A. So when I do that, here's what I get. 15 plus a negative 4. I got 11. So don't worry, right now in a little bit, I know you're seeing like, Chav, we could just do it with that graph. Okay, but there's a reason why I'm telling you guys to do it like this for now. So x of A is 11. Are we okay? Okay. So now if I want x of B, I'm going to write x of B. I could either do I could start from the beginning, 0 all the way to B, or I can start at x of A. It does not matter. So I'll do both. I'm going to say, I can say x of 0 plus integral from 0 all the way to B of v of t dt. Now I'm going to put the word or. Or I could say x of B equals x of A plus integral from A all the way to B of v of t dt. They both will give you the same answer. So I'm going to do this second bullet here. Look, x of B equals the 11 plus from A to B, that was 5, so plus 5. So that is going to be 16. So x of B equals 16. Anything crazy? They both will give you the same answer, guys, but I'm using this one. I don't want to cut it. I don't want to cut the lower limit. Ask me, miss. Ask me. Are you asking like how will this one on the top give you the same answer? Like this. No, look. Let's talk about it. Right now is a good time. Chop. How will this one give us the same answer? Well, look. What was x of 0? 15. Plus, this is for the integral from 0 to b. So if I start at 0 and I go all the way to b, negative 4 plus 5, that's going to be 1. See? So 15 plus 1. Oh, look. 16. OMG. Right? Integral from 0 to b of v of t dt. That's area under the curve. Negative 4, that's negative 4 plus 5. 1. Yeah, because it is signed area. All right. Here we go, guys. Last one. X of C equals, I'm going to go ahead and just do this one. X of B plus integral from B to C of v of t dt. Well, let's see. I'm going to write it right here. X of C equals 16 minus 24. That's what that integral is. I guess plus a negative 24, so I'll do that. Plus a negative 24. So that looks like negative 8. You could also have done, if you wanted to, I'll write it here on the side. You could have also have done this. You could have done x of c equals x of naught plus integral from 0 to c of v of t dt. And that will also give you negative 8 because you would have had 15. That's the original plus, and then you would have had this guy, negative 23. From, displacement. So what's that gap? 5, 6, 7, 8. Negative 8. See? Same answer. Cool or not cool? Don't worry, we're coming back. Okay. I don't know where to start here with this. All right, here we go. Does everyone agree? Make sure that we agree with this. Do you agree with these integral symbols? We're good, right? Okay. So check it out, guys. Let's just use basic logic. If you start at position 15, remember, this is velocity. If you're above the x-axis, you're moving to the right. If you're below the x-axis, you're moving to the left. Chop, how do I know that those numbers stand for displacement? Think about it, guys. The velocity is in centimeters per second. If I find the area of the curve, centimeters per second times second is just centimeters. Does that make sense? All right, think about it. I start at position 15. Look at that 4. That means I went 4 units to the left. What's 15 minus 4? 11. So yeah, at point A, at x of A, I'm at 11. Okay, then from A to B, when I get to B, I move 5 units to the right. What's 11 plus 5? OMG, look, I got 16 for the x of B. If you look, I know I'm cutting it down, but it's down there. Do you guys see what I'm doing? And then look, so where am I at now again? 16. So now I'm going 24 units to the left. Well, if you think about a number line, 16 and going 24 units to the left, what position am I going to be at now? So I'm at negative 8 right here. Do you guys see what we're doing? See? And it doesn't matter how you cut it. So I should have probably done one more integral. You know what? I'll put it with that one. So maybe for the good notes, in the future, I'll change it. Come to this one right here. What is the particle displacement from c equals 0 to t equals c? That's the same thing as saying integral from 0 to c of v of t dt. And we got that negative 23. See? Because that just means area under the curve, signed area, right? Negative 4 plus 5 minus 24. Child, what do you mean? Remember your little rules. This right here was integral 0 to a of v of t dt plus integral from wherever that one stops, a to b of v of t dt plus wherever that one stops, the other one better start, integral from b to c of v of t dt. OMG, all that together is integral from 0 to c of v of t dt. Do you guys see how all that is working? Maybe I'm going too fast, but do you guys see the logic? Okay. All right, turn the page. So now we know. Turn the page. Oh, but you guys might not have heard that song. It's Metallica. Do you know Metallica? No. All right. What's the formula for displacement? Here we go, guys. Displacement from now on, the calculus version is just the integral from some a to some b, where what you want to find. Okay, just in case, I don't want you guys to think that a is not this a, and that b is not this b. It's just a general formula where you start and where you stop, whatever you want trying to figure out. And what do I integrate to get displacement? Do I integrate acceleration? Yeah, that's what we just did. V of t. Chop, why is integrating this give you displacement? Guys, look how it all comes full circle. Okay, I'm going to make a connection. Put your pencils down. Okay, isn't the antiderivative of velocity just position? So look at this. If I would have, okay, don't write this down, just listen. If I would have just done this, so where do I fit it? Where can I fit it? Right here in this margin. So look at this, guys. If I would have done this, let's say for this one right here. So check it out. So if I said x of a equals, and I'm talking about this one, but don't write this down, just listen, is your initial plus integral from 0 to a of v of t dt. Well, look, if I move this to the other side, that is literally your definition of that integral. 0 to a of v of t dt equals x of a minus x of 0. OMG, that's your antiderivative rule. That's your fundamental theorem of calculus. Antiderivative of velocity is position. Oh, that's not a 9, that's an a. Position at a minus position at 0. That's what that is by definition. Do you guys see that? Okay, I just hopefully that's all making sense to you. Look how awesome this is. Everything just works perfect. Okay, are we getting this? That the first one is if you take the derivative of an integrand, you just get the inside itself. and then the second one is if you take away the derivative, then obviously that must mean antiderivative. Yeah. See? So we proved it. Gives you the inside. Yeah. Do you see that? Okay. See? All right. Now, what about distance? Tell me what we did here when we got the distance. What did we do? We took the what? Absolute value of what, though? No, not the displacement. If I took the absolute value of displacement, I get 23. I took the absolute value of. Well, okay. So instead of. Okay, think about it, guys. Okay, time out. Right now, this is signed area. If I go integral from 0 to a of v of t, I'm going to get -4. Yes or no? How do I force my integrand to give me a +4? Look, here's a big. No. Absolute value of what? Well, okay. So, let's think about it, guys. Let's have a conversation. So right now, integral from 0 to a of v of t dt will give me -4. What did I do to turn that -4 into a +4? Now, don't tell me, oh, you take the absolute value of displacement. Like in this case, it will work because if I take the absolute value of the whole thing, that -4 will turn to a +4. But look, if I do that, if I take the absolute value from 0 to c of the displacement, that would just turn that -22 into 23. So that's not going to give me the distance. So where do I put the absolute value at? Look what I did with the graph. Let's see if I can graph it. How do I get the graph to do that? Okay, no, well, I guess yeah, but what else could I also do? What am I doing with my hands? Where do I put the absolute value at? No, not around the integral. No. Okay. What do you mean by inside? The v of t. You put absolute value, guys. All right. Time out. I want to make a connection. You guys all took algebra 2 because you're here, right? All right, guys. Look, guys. If I were to tell you, okay, don't write this down. Just listen. If I were to tell you graph y equals x squared, you would graph this. Yes or no? If I tell you graph y equals -x squared, you would graph that. Yes or no? If I tell you, and I hope that you did this in your algebra 2 classes, absolute value of -x squared close, I hope that you know that would turn that -x squared and flip it back up above the x-axis. Right? We know that, right? Okay, I'm going to show it because some of you guys aren't believers. Look, guys, look. Just look. X squared, -x squared, and look what's going to happen when I go math, number, absolute value. Look, I'm putting a negative, and look what I'm doing. Do you see how I'm putting -x squared in there? Look, it's a black one. So blue, red, black graph. Blue, red. Oh, look at that. Cool or not cool? It did it so fast. Look, I'll turn off the black one. Look, there's the blue one right there. And if I turn on the black one, it's going to overlay the blue one. So it's doing it really fast. Okay, here we go. Guys. So now we're finally ready to get the distance. All right, ready, Kunduru? You're going to tell me. To get the distance, I'm still going to integrate from A to B. But where do I put the absolute value? Right here like so. Let me go ahead and make that in blue so you can see it. There's my absolute value right on the v of t right there like that. That's how you make it go above the x-axis, where everything's now above the x-axis. And now you're just going to you're just adding in the areas. Do you guys see that? Okay. So, okay, guys, can you be a robot? Yes, you can just be a robot. You'll be fine. But I don't want you to be a robot. I want you to understand the little things of how everything's connected. So check it out, guys. The next one, we're going to do it completely with a calculator. So let's see what it says. Interpret the velocity function, you need a calculator. The figure to the right shows the velocity. d of s dt equals v of t equals t squared minus 8 over t plus 1 squared centimeters per second of a particle moving along the horizontal s-axis between 0 and 5. During what time interval is the particle moving to the left, moving to the right? Okay, here we go, guys. All of us try it with us. You see that equation? Type it into your calculator. Type it into Y1. Go Y1. You know what? Let me clear everything. Second memory 712. All right, Y1. What was my equation? T squared. Okay. All right, guys. Focus. X squared minus alpha y equals to get the fraction. What do I have on the top? 8. What do I have in the bottom? X plus 1, close it, squared. All right, everyone get that? Does y'all's look like this? Okay, we're good now. We're good. So let's see what we can do. Letter A, during what time intervals is the particle moving left, moving right? Guys, this is velocity. They don't give you units. Oh, yeah, they do. This is velocity in centimeters per second, this graph. This is time in seconds. So if the velocity is positive, you're moving to the right. And if the velocity is negative, you're moving to the left. So find that intersection. Chubb, how do I tell the calculator to find that intersection? Let me show you guys. First, before you even start, guys, do we know how to mess with the calculator to tell us this grid here, 0 to 5, negative 10 to 30? So, yeah, click on window. Click on window and put 0 to 5. See, like that. And then negative 10 to 30. And then let me see what they're doing their scale by. Do you remember? 5, 10, 15, 20, 25, 30. Go by 5 on the y-axis. The x-axis is going by 1. So y scale by 5. Push enter. Check it out. Boom. There it is. Yeah, it looks similar to what they have drawn. Okay, guys, you have to do nothing by hand. So check it out. Second, calculate. Which one am I going to use? The 0, because that's where the y value is 0. And then it's going to say left bound. So it wants to know where. Where am I going to look? Look between here, enter. And right bound, look between here. Go to the right of that, enter. And it's going to say guess. That's if you have several. Like if you have a lot of zeros, you go to the closest one. You only have one. So make time fast, just push enter. No, I don't want to guess. And there it is. It needs to say the word 0. 1 point, how many digits do you need? 3. 3 after the decimal. 2545447. So here we go. I'm going to go to my calculator. And I'm going to go moving left on the interval. Parenthesis. Oh, actually bracket with the 0. 0, comma 1.2545. 2545. Technically we're supposed to put a bracket in there. Since velocity is negative on the interval 0, 1.2545 with a parenthesis. Technically, you're not negative. I guess if you put, okay, I'm saying too much. I already wrote it. I was going to say less than equal to 0, which would have been perfectly fine. And then you could have just said on this specific interval. But I put less than 0. Technically, at the 1.2545, you're 0. So that's why I put the parenthesis. But if you were to put parenthesis, there wouldn't have been a penalty, but your professor might fight you, maybe. At the college, at the reading, we'll be fine. You'll get full credit. Are we cool? Let me switch my pen to blue. Moving right. This is a closed interval. Moving right on the interval. Bracket 1.2545, comma to 5, close bracket, since v of t is greater than or equal to 0 on this specific interval. There, you got both worlds. If it irks you that I put an equal sign on one and not on the other, then just say since v of t is greater than 0 on the interval 1.2445 with a parenthesis and then close the 5 with a bracket. If you don't know whether to use brackets or intervals or parentheses, which one's the safest route? You can put parentheses on everything and you'll be fine. Now, don't go overdo it. And Chavez said to put parentheses everywhere. Like, that's not what I'm talking about. I'm talking about intervals, guys. If you're scared, put parentheses on all your intervals, you'll be fine. But we're not teaching you to the test. We're not teaching you to hack. I know you want your points. Like, I want my points. I'm going to put parentheses everywhere. Relax. Correct math is correct math. All right, here we go. Suppose the initial position of the particle in example 1 is 9. That's how they say initial position. What's the particle position at t equals 1? Okay, help me out, guys. Here's what you're going to write. S of 1 equals, and look back at your notes. So what am I going to write? S of 1 equals, what's my initial position? So I'm going to write S of 0 first, and then what do? Plus what? The integral from what to what? 0 to 1, because I want to know my position at 1. And what do I put inside this integrand? Perfect. You can just go right to the answer from here. Many times the rubric will have like a 9 in the front. That's fine. Both are taken because that 9 is S of 0. All right, how do you do it in the calculator? Look, guys, check it out. You have to do nothing. Well, you had to push buttons, but don't already have my equation, my velocity, and y1? So look, everyone do it with me, guys. Ready? On the home screen, you're going to go math, number 9. I should have done the position first. That's fine. From what to what? 0 to 1. And instead of typing that whole long expression, you already have it. Where do I have it saved at? So go alpha trace y1. See, there's no reason to type the whole thing out again, guys. Alpha trace y1. Push enter. And then there it is. Push an X in there and push enter. Now be careful. That's not your answer. That's just a displacement. What do I add to that? Plus 9. So maybe I should have done it from the beginning. 9 plus. So here it is. Here it is again. So practice, guys. Practice. So do it again so you can practice and get used to it. Maybe create muscle memory so you can just be fast. Alpha trace y1. There it is. 5.333333. Hopefully your calculator is staying the same. If your calculator is doing... Oh, by the way. Yeah, I already started saying this. So, guys, there was just an update to TI-84CE. What does it do? It makes it tightens the tolerances on your graph. I don't want you finding the area under the curve through the graph. You can look. It's one of the options. Second, calculate. Look, it's right there, number 7. Don't use it because the tolerances might be different. I'm telling you, maybe I shouldn't have even mentioned it. Yeah, because look, watch 7, and then if I say, what was my lower limit? What was my lower limit on this one? 0. What was my upper limit? 1. Look, guys, let's see if it does it. Yeah, it does it pretty good, but it doesn't always. Okay, be careful. It's happened. Okay, guys, focus, everyone. Guys, I'm telling you right now, it's happened. I've seen it. I've been a reader for a long time. I've seen exams that I know that the kid got the area under the curve using the grapher, and it was off by a little bit. Do you think they got the point for the answer point? No, because it has to be exact. Now, the update takes care of it. It looks like they tightened the tolerances. For the perfect answer, I would always use, whether you have the update or not, I would always use the home screen. I just don't trust the grapher, even with the update. Supposedly the update fixed that issue. If you don't have, do you guys still have your USB cables for the ones that bought it? If you don't have it, bring your calculators to me. I'll update the operating system. Not today because I gotta update mine. I'm sorry, what? Just recently, like 3 weeks ago or 2 weeks ago, just recently. So yeah, don't worry. I'll update. We can update your graphing calculators. All right. What was the answer again, guys? 5.333. You can also turn that into a decimal fraction. All right. Here we go, guys. S of 5. You can either use well, in this case we're going to use the S of 0. You could use the S of 1, the 5.333, but just use the S of 0. S of 0 plus what's up? What was your side note? Oh yeah, don't worry about the side note. Integral 0 to 5 v of t. No, it's because if I bring it to your attention, then you might have bad habits. But now look, we've been doing v of t all this time. You know what I mean? So it's because I put more thought into it, and now okay. No, I put a lot of thought into y'all's lessons. All right, here we go. YouTube's cool. Here we go, guys. Let's go ahead and practice. Practice, guys. 9 plus math 9 from 0 to 5 of alpha trace y1 x. 44. A perfect 44. Cool. Very cool. All right. Here we go. Find total distance traveled by the particle in example 2. All right. Total distance equals. All right, guys, focus. How do I find the total distance? What do? The integrand is still the same. From what to what? 0 to 5. And then what do I put in here? Absolute value of velocity. Absolute value of velocity. All right, here we go. I take my calculator. Here we go, guys. Take your calculator. Practice with me. Push the math button. Push the number 9. 0 to 5. Chav, how do I put the absolute value in there? That's why we're going over it right now. How do I get the absolute value? Push the math button. And these in the top are called tabs, just like, just like every day. These are tabs. So go to the number tab and look at the very first one. It says ABS. Do you guys see that? Push it. Boop. And look, there it is. Absolute value. Now I'm going to push alpha trace, and I'm going to type in the Y1, and then I'm going to get out of there. And then for the D, I'm going to put the X there. And I'll push enter. And there it is. That is the total distance. How many digits after the decimal? 3 minimum. And there's a perfect one, truncated or rounded, it does not matter. I actually prefer that you write all the digits, 4 or 5 of them. 42.5868. I'm going to put all those. 42.5868. You could have said 587 or you could have said 586. I prefer to put putting more digits. You're safe if you put more digits. Cool or not cool? All right, there it is. If there's units, put units. I don't know if there's units on this one. Centimeters. Yeah. This is centimeters. This is centimeters. This is centimeters. I guess that's a position that's centimeter, whatever mark. All right. Check it out, guys. We're almost done. The integral is a natural tool to calculate net change and total accumulation of more quantities than just distance and velocity. Integrals can be used to calculate growth, decay, and in the next example, consumption. Whenever you want to find a cumulative effect of a varying rate of change, integrate it. Demand a third edition. Now, look at all that we learned just by that one little paragraph. Chav, how do I find out what the units are? Guys, let the units, analysis help you out. So look at this example. From 1970 to 1980, the rate of potato consumptions in a particular country was C of T equals 2.2 plus 1.1 raised to the power T millions of bushels per year, with T being years since the beginning of 1970. I'm assuming this is a real formula, that someone studied some country and was like, here's the model. All right. How many bushels were consumed from the beginning of 1972 to the end of 1973? Okay, Chav, how do I do this? Well, we're finding area of the curve. Look. All right, guys, slow down. C of T is millions of bushels per year. It's a rate. So think about it. If you graph millions of bushels per year and you find the area under the curve, millions of bushels per year times years, because the x-axis is in years, is going to give you bushels, millions of bushels. Does that make sense? All right, so that's what we want. Now, Chav, I'm going to integrate, and I'm going to start at 1972, and I'm going to go to 1973. Guys, no, that's not how this works. Notice where they tell you, look right here. With T being years since what? Since 1970. So the beginning of 1972 is T equals 2. Now be careful, read it very carefully. This says the end of 1973. So it's not T equals 3, it's T equals 4. That's like saying the beginning of 1974. Does that make sense? All right, so here we go. From 2 to 4 and of C of T dt. You could also write the expression 2.2 plus 1.1 to the T, but it's safer to just write C of T. Equals. All right, guys, focus. I'm going to put my integral. So here I'm not going to type it on Y1. I'm just going to go right into it. Math 9 from 2 to 4. And what was it? 2.2 plus 1.1 raised to the T. So there it is. And if you want, you can put it into a Y equals, but I just went ahead and just typed it in there. I got 7.066. Is that what you guys got? So here it is. I'm going to go 7.066, and I need units. Just bushels or millions of bushels? Millions. Am I saying it wrong? Millions of bushels. That's how much was consumed. So hopefully you're seeing how this can be used. All right, last one. I like this problem the most. You're the city engineer. You're the boss. You're the engineer. And you give the apprentice or whatever, you tell them, here, man, I need you to record, or lady, here, lady, I need you to record all the rates, because you have a motor that's giving out the rates. It's just giving you the rate of how fast it's pumping. And here it is, and you recorded that. And now you being the engineer, is going to find out how much water you just pumped. Come on, engineers, focus. All right, so look what it says. A pump connected to a generator operates at a varying rate depending on how much power is being drawn from the generator to operate other machinery. The rate, gallons per minute, at which the pump operates is recorded at 5-minute intervals for 1 hour, as shown in the table to the right. How many gallons were pumped during that hour? So you're the engineer. Let's figure out how many gallons were pumped, approximately. All right, notice all of them have 5-minute intervals. Cool or not cool? So I'm going to use this formula, h over 2, y naught, plus 2y1, plus 2y2, plus ... 2, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, plus 2y12 plus y13. Actually, I'm just gonna put the general formula, so I can't count sometimes. 2yn minus 1 plus y's of n, where y's of n is the last one. You don't have to do it like that. N minus 1. Second to the last one. And then the last one is y's of n. All right. What are you trying to cancel out? Don't cancel out anything. 5 over 2. Oh, so then this would have been 12, and then that would have been 13? No, if you have 12 trapezoids, then you need 13 points. All right, 5 over 2. Does everyone know where I got the 5 over 2, guys? And then this is the height of your basis, quote unquote. 58 plus 2 times 60 plus 2 times 65 plus, I'm going to put ... plus, and I'm just going to put the last 2 here. 2 times 63 plus 63, close parenthesis. Do you guys know what I did or no? Okay. In case you don't know what I'm doing, guys, I'm just using a formula. Chav, why are you using that formula? Because, look, guys, this 2, because I don't want you guys to become robots. Those 2 come from this. I could have gone 58 plus 60 times 5 divided by 2 plus parentheses 60 plus 65 times 5 divided by 2 plus 65 plus 64 times 5 divided by 2 plus ... Look, guys, I have a 5 over 2 on all of them. See? So 5 over 2, parenthesis, and then look, if I go 58 plus 60 plus 60 plus 65 plus 65 plus 64 plus ... Look, how many 60s are there? 2. How many 65s are there? 2. And it kept, see how it kept going? So that's where the formula comes from. You can only do that when they're equal like that. All right, someone tell me what you get as a number. What is it? 3,582.5. And give me units. Gallons. Make sure you try it, guys. Make sure you try it. Yes. You got to put them all.
Did you not which type of facts?
Look, guys, say that again.
Did you not use that in the stats and put it in the table and then have...
Yeah, but remember there's a 2 in the front.
Yeah.
So you would have to do it in the table also 2 times, whatever. Do you know what I mean? Yeah. All right, look, guys, try it out, guys, because we all make mistakes. That's what we got this morning, but hopefully, okay, give me the numbers. What was the first one? 58 plus 2 times 60 plus 2 times 65 plus 2 times 64 plus 2 times 58 plus 2 times plus 2 times plus, is it another 2? 2 times another 55? 55 plus 2 times 59 plus 2 times 60. I guess you could, but then you'd have to have a half on the first and the last. Plus 2 times 60 again. Oh, plus 2 times. Okay, and then there's the last one coming up, right? Close parenthesis, and let's see if we got the same thing. Oh yeah, math decimal. 3582.5. And what are the units? Okay, see, you're the engineer and you figured that out. Cool or not cool? All right, guys, everyone should have a handout. You just have like 5 or 6 questions. Let's take care of that. You got about 40 minutes, 38 minutes, which I think is enough for those 6 questions. And no, I did. I passed it out. Oh, I didn't pass it out to you guys. Okay. All right. That's it, guys. Take care of business.